Uh, so in this video, we'll actually explain. I'll try to explain the number 4 puzzle from the book 50 Challenging Problems in Probability. So the puzzle number 4 actually states that on average, how many times must a six-sided die be rolled until a six turns up? So let's move into the solution. So first, we have to actually find the number of rolls. So we have to find the number of rolls until a six is achieved from the dice. So let's first assume that S is the variable which represents the number of rolls required to get 1 6. Now, so S is the variable here, and the dice is actually if the dice is identical, then the probability of getting 1 6 is should be 1/6, and that is because the possible outcomes are 1 to 6. So the possibility of getting 1 6 should be 1 divided by 6, and so the probability of not getting a 6 is that should be 5 divided by 6, and that can be actually derived from 1 minus 1/6, and that should be 5 divided by 6. So to get the solution, let's first assume some common things here. So let's assume that we actually need to roll the dice m times to get a 6. So the possibility of getting a 6, which is denoted here is by p of s, that is it should be 1 divided by 6, and the probability of not getting a 6, which is denoted here, is by p of s bar. This should be 5 divided by 6, and m is the number of times the dice is rolled to get a 6. As mentioned previous, the probability of getting a 6 when m is equal to 1, or we have actually, or which when m is equal to 1, it means that we have actually rolled the dice for once. So the probability of getting a 6 should be 1/6. And now if we actually roll the dice twice, what will be the probability here? The probability will be what will the probability of getting a 6 when m is equal to 2? So when m is equal to 2, it is like 1 divided by 6 into 5 divided by 6. That is because the probability of getting 1 6 should be 1 divided by 6, and in the second roll, the getting not getting a 6, that should be the probability of not getting a 6 should be 5 divided by 6. And as these incidents are independent, so it should be multiplied here. Now think about that. What should be the probability of getting a 6 when we have rolled the dice thrice? So in that case, it should be the probability of getting 1 6 when m is equal to 3. It should be 1 divided by 6 into 5 divided by 6 to the power 2. So we can actually get a nice equation from here, and that is uh, the probability of getting a 6 when we have tossed the dice for m times. It should be 1 divided by 6 into 5 divided by 6 to the power m minus 1. Here, when m is equal to 2, the power of 5 divided by 6 is 1. And here, when m is equal to 3, the power is actually 3 minus 1, 2. So so on and so on. So if we actually roll the dice 4 times, then the probability will be 1 divided by 6 into 5 divided by 6 to the power 4 to the power 3. And we can actually roll the dice from dice infinite times, and we to find the average value of this m, we need to actually consider all the values ranging from 1 to infinite. And uh, we have to actually consider all these conditions when m is equal to 1 to m is equal to infinite, and we have to find the average value of value in this case. And to find that average value, we have to actually then calculate the expected value. The expected value of s, which is generated here, is by e of s. Now, by definition, expected of value is the sum of product of the number of incident into the probability of an incident. So here the number of incident is m, and the probability of getting 1/6 is like p of s into p of s bar to the power m minus 1. Here p of s denotes the probability of getting a 1/6, and p of s bar denotes the probability of not getting 1/6. So if we use this formula, then we have to sum this product from for m is equal to 1 to infinite, and then this value of e of s will actually give us the average number of rolls that we need to do to get a 6. So in other words, this expected value can be actually thought like it's the generalization of of weighted average of a large number of independent trials. So previously we have seen that the probability this value of p of s is equal to 1/6, and the value of p of s bar is equal to 5/6. Now what we have done in here is we have actually multiplied this equation by 6/5 to make it to make this m minus 1 to m. So if we multiply this number by 6/5, that will be 5. In that case, the power of p of s bar should be m, and to keep the balance here. So in other words, actually, if we want to make this p of s bar bar's power from m minus 1 to m, then we have to actually multiply it by 6/5. So that will keep the balance here. So now we actually know that the sum of m multiplied by r to the power m from where m is equal to 1 to infinite, it can be written or expressed in simple terms, and that is r divided by 1 minus r square square. So if we actually go back to the so if we actually use this equation here, so we can actually simplify this expected value of s here. So here I've just gone back to my previous slide. So here this is 6/5 into 1/6, and now we are actually simplifying this equation by the equation described in the next slide. So if we actually, so here r is 5 divided by 6, so we can actually simplify this equation, and then if we calculate this value, it should be the e of s should be 6, which means that we have to roll the dice 6 times to get a 6 here. So that's the solution actually for this math, and thanks for watching. Yeah.